So what are isotopes by the way? We already know something in chemistry as well. So what is isotopes? Alicia?
They have the same like proton number of protons and electrons, but they have different number of neutrons.
Yeah. So an atom of the same element having different number of neutrons, but same number of protons. Okay. So definitely due to that, they have a different uh, physical properties, like radioactivity is one of them. So just write the definition of isotopes then. Why we study this isotope thing, there is a reason. So let's, once you understood by the meaning of, this all, what is uh, isotope and everything. Now let's jump to what radioactivity is, because then and only then we will be able to actually know what exactly is radioactivity and what exactly is the other thing. So now radioactivity. Now I tell you one thing. There are two type of radioactivities. First of all, one radioactivity is called as spontaneous radioactivity, which is actually occurring itself, and one is artificial radioactivity. Artificial radioactivity activity we do not have in our course. It means that we do, make this radioactive elements by ourselves by adding something into that. And what we are studying is the natural radioactive elements. That is actually happening naturally. And mostly it happens with the elements having atomic number, or you can say proton number, more than 91. More than 91. By the way, there are some naturally occurring elements are also available whose atomic number is not more than 91, but less than 91, very much less than. But they are naturally occurring element. I'm talking about those whose elements are, whose atomic number or proton number is more than 91. Now, what could be the reason for that? Very simple reason. If the atomic number or proton number is 91, right, it means their nucleus is quite big. There are 91 protons in that, and definitely there must be some neutrons into that as well, which makes this nucleus a bit big. And then now 91 electrons. It means that there are multiple energy levels, or you can say shells, in which electrons are flowing. So what exactly happened in that case? If there are too many shells, that make the size of an atom abnormal, quite big as the normal size. So those electrons which are in the outermost shell, these haven't have a, well, you can say, a force of attraction between the nucleus and that electron, because you know why there is a rotation around the nucleus for this electron, because of the inter what you call it, interforces between the nucleus and the electrons, right? But the outermost electrons, their forces, or you can say their attraction for the nucleus, or force of attraction between the nucleus and electrons, are not that much enough. So what happened? That big abnormal nucleus will no more be stable anymore, and they become unstable. So what happened? To make themselves stable, they start releasing different type of different type of particles from that. We do call them particles, we do call them radiations. While they are actually passing on the radiations, they convert themselves into more stable elements or more stable nucleus. So the phenomena of getting themselves disintegrated or breaking up into different element by radiating different type of elements or different type of particle is called as radioactivity. And those elements which undergo that kind of change, we call them radioactive materials or radioactive elements, whatever you want to say. So the reason of them to disintegrate themselves is to make them stable, right? I can give you an analogous example so that you will understand better why they actually want themselves to be stable. Alicia, my question to you, it's not directly linked with our subject, but my question is, do you know why the reason is, what is the reason why Russia, a very big country, broken down into small pieces?
Um, I'm not sure.
Manur, what's your point on this? Why a big country named Russia broken down into small pieces like Turkmenistan, Tajikistan? What's the reason for that?
It's easier to control.
Yes, the point is actually it was very difficult for a very big country to control each and everything. In time of Gorbachev, actually, Russia wasn't controllable anymore. It was very big, very big. So those areas which are quite far away from Moscow, the capital city of Russia, they cannot be controlled. So for America, it will be very easy to penetrate into, and for them actually, it will be very easy to actually broken down into small pieces. That is the reason each area, whatever area was a part of Russia, it broken down into itself a small country. What my point is at this point is consider this nucleus as a unstable country. So what it does, it broken down into small countries to make themselves stable. What they do, they release different type of radiation from them. So make themselves, what you can say, make themselves 101% same as the stable nucleus. They release different radiation or particles. This process is called as radioactivity. Any question related to that?
No, sir.
No, sir.
Okay, I want you to write few lines, put a heading radioactivity. Radioactivity occurs when the unstable nucleus of an atom undergoes a fundamental change, or disintegration or decay, 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 that results in different nuclei, results in different nuclei, NUCLEI, of an atom being formed and accompanied by emission of alpha, beta or gamma radiation, formed and accompanied by the emission of alpha, beta or gamma radiation. Next bullet point, radioactivity results from the random and spontaneous breakdown of the unstable nucleus of an atom. Next bullet point, those nuclides which performs radioactivity, which perform radioactivity are called radioactive materials. Now there is an example which is being done for you. I want you to write a question on this. It's already done, by the way, but you tell me quickly. That's a sodium 2311 is given here. Can you tell me how many numbers of proton, neutrons, and electron in this particular nucleus?
11
And
electrons.
11 electrons. And what about number of neutrons?
12.
How did you find out? You simply subtract the nuclide number or nucleon numbers with the mass number by atomic number, right?
Yes.
Okay. So that is what it is. Okay. Now let's move on. Okay. Now, once you understand with this, now those material which are coming out, definitely we have to analyze them as well. What are those? So let's do the analysis of what particles or what radiations are coming out of it. We will talk about this later. What exactly are they? I mean, first of all, we need to understand what exactly are they, and then we will see their equations as well. But this thing we will do it later on. Now, let's talk about, now first thing first, here comes alpha, beta, gamma radiations, because these are the materials which are coming out while these elements are changing themselves into more stable nucleus. So now put a heading, properties of alpha, beta, and gamma radiations. The third one is not a part of our course, so we don't have to. First, put a heading, alpha particle. First thing, alpha particle, sign is that, or you can say that they are helium nucleus. Now, helium nucleus, along with that, they have a positive 2 charge. It means that 2 electrons are actually removed. It's not like this actually, it's like that. So 2 electrons are already removed from that. That's the reason it has positive 2 charge. So basically, they can be mentioned as like this as well, with positive 2 charge. So first point is alpha particles are the helium nucleus of 2 protons and 2 neutrons, where proton number is equal to 2 and nucleon number will be equal to 4, and nucleon number will be equal to 4. These helium nucleus, after full stop, these helium nucleus have 2 electrons knocked off. 2 electrons knocked off. 2 electrons knocked off. It means that alpha particles are positively charged particles. Alpha particles are positively charged particles with a charge plus 2. With a charged plus 2. Now write their representation. One representation is that very simple. One, you can put mass number on the top, this at the bottom, or you can do the same thing here, 4 here, 2 here, plus 2 like this. But mostly the books are writing in that way. Either this way or either very simple. These are 4 representations. So write them, please. If they are positively charged in electric field, which electrode they will deflect towards? Yes, Alicia and Manu, positively charged, right? So which electrode they will actually deflect in electric field?
The cation, the cathode.
Cathode, negative. So that's what our point is. Alpha particles deflect towards cathode, deflect towards cathode, which shows that alpha particles are positively charged particles. Alpha particles are positively charged. Now, third point, alpha particles are traveling. Alpha particles are traveling. Alpha particles are traveling 1/10 the speed of light. Alpha particles are traveling 1/10 the speed of light. So their speed is also less than the speed of light, but just 1/10. So approximately it can be 3 into 10 raised to power 7 meter per second. Next bullet point. This is called penetration power because they are big elements, big particles. So they have a very less penetration power, or you can say out of these 3, alpha, beta, gamma, alpha got the lowest penetration power. So next point is alpha particles have the lowest penetration power. Alpha particles have the lowest penetration power as compared to beta and gamma radiations, as compared to beta and gamma radiations, as compared to beta and gamma radiation. Continue with that. Being the biggest mass and charge, being the biggest mass and charge, they can be stopped by a few centimeter of air. They can be stopped by few centimeter of air or thin sheet of paper. Thin sheet of paper. Alicia and Manur, any problem in that? Very simple thing, because they are big elements like helium nucleus you are talking about. So very easily they have a very less penetration power. To penetrate into something for them is very difficult. So as a being a the largest elements or being the largest particles, they can be easily stopped by the paper and of course by air as well. You can stop them very easily by using a paper sheet. You put a paper sheet right in front of alpha particles and they will be stopped. Paper sheet will absorb those alpha particles and they will be stopped. Right? Any issues?
No, sir.
Alicia?
No, sir.
Okay. Now the next is called ionizing power. What do you think the ionizing power will be? If they say ionizing power, it means that if somebody have the ionizing power, it means that it has an ability to knock off the electrons from some element so that it becomes ions. Because that's how the ions will actually form. The electrons will be removed and they become ions. So basically, ionizing power means that somebody has a power to actually knock out or remove the electrons from some nucleus. And when they remove the electrons from that nucleus, it will be converted into ions. That's what the ionizing power is. What do you expect? Alpha being the biggest, what about their ionizing power?
It has the highest.
The reason is they are the biggest. They are, as far as size is concerned, they are the biggest one. So for them, removing the electron from the atoms is very easy, right? So first of all, in the next bullet point, let's write the definition of ionization. Ionizing power. Write a small bullet in which write ionizing power and then write the definition. The ability to remove electrons, the ability to remove electrons from atoms to form positive ions, to form positive ions. The process is called ionization. The process is called ionization. Now continue with that, but a bit like make some distance of 2-3 words. Alpha particles being the largest mass, alpha particles being the largest mass and charge have the highest ionizing power as compared to beta and gamma radiations. As compared to beta and gamma radiations. Continue further. So you can say that alpha particles have the biggest punch. Alpha particles have the biggest punch in ripping off electrons, in ripping off electrons from molecules to convert them in ions. To convert them in ions. Now next bullet point. Alpha particles also show deflection. Alpha particles also show deflection in the magnetic field. In the magnetic field. In the magnetic field. So as they show deflection in electric field, they turn towards cathode. Same thing happened when they are in magnetic field, because of they have a positive charge. So they show their deflection in the magnetic field. Okay. But remember that whatever their deflection will be, it's totally reverse of the beta. Can you tell me the reason why they both are deflecting in two opposite directions? Because one is a positive charge one and the other one will be having a negative charge. So even in magnetic field, they deflect, they show their deflection, but it will be like this. For example, if alpha particle goes this way, beta particle goes this way. So if one goes anti-clockwise, the other goes clockwise. All right, you two? Alisha and Manur, any issues?
Yes.
Yes. No.
So how many points do you have, these bullet points? Count them, please. Yes, how many? So these are the 6 points for beta and these are the 6 points for alpha, gamma as well, but definitely different about it. Now put a heading beta radiations or beta particles. First bullet point. They are the fast moving, they are the fast moving high energy electrons whose charge is equal to -1, whose charge is equal to -1, whose charge is equal to -1. Now, next continued line, their representation, they can be represented by this beta sign with a -1 on top, or it can be E with a -1 here and 0 here because they have negative charge. Next bullet point, beta particles are traveling, beta particles are traveling with the speed, with the speed nearly equal to the speed of light, nearly equal to the speed of light, nearly equal to the speed of light. Beta particles have the moderate penetration. Beta particles have the moderate penetration amongst alpha and gamma radiations. Among alpha and gamma radiations. Amongst the alpha and gamma radiation. They cannot be stopped by, not instead of writing that, you can say they will, just wait. You can write by this. They can be stopped by few millimeter of metals, few millimeter of metals like aluminium, and will travel quite a few meters in air, quite a few meters in air, and they will be definitely stopped by, and they will be definitely stopped by a few centimeter layer of concrete, a few centimeter layer of concrete, and a sheets of lead, and a sheets of lead, and sheets of lead. Next bullet point. Have the beta particles have the moderate ionizing power. Beta particles have the moderate ionizing power as compared to alpha particles, but still quite good at knocking off electrons from molecules, knocking off electrons from molecules. Okay, students, we have missed one point actually, that in electric field, they turn or they deflect towards anode, which is positive terminal of the battery. So that point now, in an electric field, beta particles shows deflection, beta particles show deflection towards positive terminal, towards the positive terminal. In the bracket, write anode, ANODE, anode. Next bullet point. Beta particles also show deflection. Beta particles also show deflection in the magnetic field, but in the opposite direction, than that of alpha particles, alpha particles. Students, any problem in this?
No,
No,
sir.
sir.
Very simple. Now, gamma particles or gamma radiation. Gamma particles, write some line. They are very high frequency. They are very high frequency electromagnetic radiation. Electromagnetic radiations with mass and charge equal to 0. With mass and charge equal to 0. Now, the same point, they are represented by that sign and that sign. So you can write both this one as well as this one. This shows that its mass number and proton number both are 0. So this sign as well as this sign. This is called gamma sign. Next bullet point. Now, being the weakest or you can say massless particles, they have a very high penetration power. Okay. So that's what we are writing. Gamma particles, gamma particles being the massless entity, being the massless entity, have very high penetrating power, very high penetration power or penetrating power. They can stop by a thick layer of steel. They can stop by a thick layer of steel or very thick layer of concrete. Thick layer of steel or very thick layer of concrete. But even a few centimeter of dense lead, even a few centimeter of dense lead does not stop all of it. Gamma particles can be easily passed through, many meters of air after full stop. It takes many meter of concrete plus steel. It can take many meters of concrete plus steel to absorb it. Okay, students, I think we better stop it here. Okay, in the next class, we will move from here. Okay, tell me one thing. After alpha, beta, gamma, and their reactions, what do we have in that? Do we have that head-ons and all these element quarks are also part of it? I mean, paper one.
No, sir. Quarks are not like part of our course.
Quarks are not the part of your course.
No, no.
Then what are what
Probably
head-on
A level.
again?
It's probably in the later part of the course.
Okay, okay, okay. So that's it. Alpha particle, beta particle, and that's it.
There's also half-life.
No, no, I know. Other than this radioactivity, we don't have anything else. I mean, no head-ons and all these red-ons, something like that.
We have neutrinos, antineutrinos.
No, no, I know this. I mean, the other elements like I was talking about head-ons and all this quacks, definitely they are not part.
Yeah,
No,
they're not.
we don't
Okay,
have
okay.
that.
Okay, okay. That's fine. Yeah, half-life definitely. We will discuss that. I got the numericals as well. And reactions definitely a part of your course as well. Because beta, when beta decayed, there is a thing which actually I will discuss while the things will come as soon. Okay. So hopefully see you
Yes.
tomorrow then. Okay. Bye then. Take care.
Okay.